All right, so here's another podcast where you have to prove using your quotient and reciprocal identities. So once again, an approach is to rewrite everything in terms of sine, cos, or tan. So as you can see here, cos theta can just stay exactly how it looks. You can manipulate cotan in two ways. Actually, you can actually put that as cosine theta over sine theta, and that goes back to the quotient identity. So far I have cosine theta minus cosine theta over sine theta. Okay, and this is all over 1 minus sine theta. So that's the left-hand side so far, but on the right-hand side, I can even simplify this again or rewrite that using an identity, and that will be the quotient identity again, so negative cosine theta over sine theta. Okay, so as you can see here, both these sides do not look anything alike right now, so we have to play around with it a little bit. So right here on the top here, as you can see, we have a fraction minus a fraction. So you can actually put those fractions together by creating the same denominator. So for the first fraction here, it's the only one I need to manipulate. I want to multiply both the top and the bottom by sine theta, and that will create the same denominator. So what I'll have left now is cosine theta times sine theta all over sine theta minus cosine theta over sine theta. So remember, I didn't do anything to do that to the top, and this is all over 1 minus sine theta. Okay, and we're trying to make it equal to cosine theta over sine theta. Now, I can't play around with the right-hand side too much. That's as far as I can go with that. So let's go ahead and manipulate the much bigger side, which is obviously the left-hand side. So as you can see here on the top, both these fractions can now be combined into one because we have the same denominator. So what we have now is cosine theta sine theta minus cosine theta all over sine theta, the common denominator, and we're still dividing by this binomial. So what you could do here to simplify this question is, instead of dividing it by 1 over sine theta, that's the same thing as multiplying by its reciprocal. So 1 over 1 minus sine theta. So I'm just rewriting it as a multiplication question instead of a division question. It gets a bit confusing when you have stacked fractions. So from here, you want to see if you can cancel anything out. You still can't. So from here, you can go ahead and look at the top here. Notice that you can actually factor something out. So once again, proving identities, you just have to play around with it. So cosine theta can actually come out from the top. And what I'm left with is sine theta minus 1 all over sine theta. And remember, we're multiplying this whole thing by 1 over 1 minus sine theta. And that should equal cosine theta over sine theta once we start canceling things out. Okay, so far this is what we have. As you can see here, we do have things we could cancel out here. As you can see here, this binomial 1 minus sine theta is almost close to sine theta minus 1. What we have to do here to create this same binomial is actually factor out a negative. So I'm actually going to factor out a negative from this binomial up here. Doesn't matter which one you choose. So if I factor out a negative, this ends up being cosine theta, but now a negative because I factored it out. And that's going to change the signs in the binomial. So this will now become negative sine theta plus 1 all over sine theta again. Okay, and then brackets, 1 over 1 minus sine theta, okay, is equal to negative cosine theta over sine theta. So we created the same binomial here. Notice that this binomial, 1 minus sine theta, is the same thing as this binomial, but just in a different order. So since these are the same, both on the top and the bottom, they can actually cancel out. So what I'm left with now is negative cosine theta on the top times the 1, but that just gives you the same thing, negative cosine theta. And then on the bottom, all we're left with is sine theta. And I believe I have proven my identity because now both sides are equal to each other, so that completes my proof.